I love problem solving. We really want to have projects that are fun, that are gonna challenge us. And a lot of the stuff we do, no one is doing. My name is Forgione, and here at Forgione Engineering, we're primarily a mechanical engineering firm. We also do structural engineering, electronics, and what I consider full service engineering. So anything from additive manufacturing, machining, any traditional techniques, welding, water jet cutting. We have tons of different tools that we can use in design. So a lot of times we design in 3D. Sometimes it's very hard to start in 3D. So a lot of times you'll see us with pencil and paper. This here is a lattice structure that's printed in carbon fiber and nylon. We use this as an infill for 3D printed products. So one of the things we're looking at right now is actually for a golf club. We can actually control the infill and control its stiffness through the parts, so we can actually make certain portions of it stronger, some of them more flexible. But it's so nice to be able to take and look at something in 3D, design it, and analyze it before we even make it. With this one here, this gets clamped onto a shaft that goes down into the ground to the bottom of a foundation element. And as they load test the element to figure out what its capacity is, you can measure the movement of the tip of the foundation, and you put a dial indicator on there and read the movement sometimes in thousandths of an inch. And here you can see the layers, so it's showing layer by layer as it's printing what it'll do. We used to make them out of metal. We'd just take a shaft clamp, we'd weld a little paddle on there. And the nice thing about this is it'll keep the dial indicator from falling off because it kind of has a little rim around it. And the quartz window is ground perfectly flat and smooth, so there's no way it's going to get hung up or have any other issues that are common problems with the other technique of doing it. We can print like 10 of them a day, and if we need to make a change to it, we just go into the CAD model, we open it up, we can add additional reinforcing, so we can load that up, we can put Kevlar in it if we want. The most important thing for us is to know when to use the right tools for the right projects. You know, in some cases we'll have a small project where it might be like a tiny little component, you know, it could even take a couple hours. This here is actually an extension for a huge excavator specifically for material handling. So we designed this, we helped fabricate it, and it's on a machine today, and they've been using it for 2 years. We also do the entire stability analysis and structural analysis on it, so we have to figure out what can the hydraulic cylinders and the hydraulic system in this machine actually handle and make sure that we're not going to overload it. So we have to look at different configurations of the mechanical positions of the linkages here and determine how much they can lift up. So I think in this case they can pretty much pick up about 25,000 pounds in certain positions. In some cases we get involved with things that what I would call mission critical type operations where, for example, we may design something to be lifted in downtown Boston, and it might weigh 100,000 pounds. It needs to be lifted with 2 cranes and actually picked up and tripped vertical and then put into the ground. We could work on something like that for 2 or 3 months to look at every possibility and every piece of hardware and where the stresses and the loads are going to be and the stability of the cranes and different positions of where those can be. Working in Lowell is really nice because you know, we have the university where I'm an alum. Ironically, we're sitting here in a location where the textile and industrial revolution was founded, right in this building. The city is like a big small town. A lot of the businesses work together. It's nice to be here developing the business and trying to also be integrated into the community. We start by just going in and trying to understand what the client needs, what their pains are. It just starts by listening, and people have always said, you know, you can listen to what we said and you turn it back around. Our tagline is, you know, engineering real solutions. And that's the basis for what we do, is just cutting right through all the noise and figuring out what is the problem and how are we going to find a solution to that problem and give it back to you. Because at the end of the day, that's all that matters.